Yeah, hello guys. This is the Tech phone clinic. This is Xylot's speaker. According to the customer, he said she was charging it and it didn't just stop and it stopped working. So when she brought it, I tested it. I tried to power it up. It's not coming up. So at times it will come up, at times it will not come up. So we'll be checking the speaker right now. So now let us test. This is the right speaker. This is the speakers. These are the speaker. This is the left hand side speaker. And this is the battery. And this connection is for the mic, but we are not connecting the mic. And this connection is for the that is for the volume, the modes and the minus and the side view. So we're not connecting that also. So let's connect. So now let's power it on.
Welcome to use Xylot products. Bluetooth mode.
So now we have, it's giving us sound. You can see it's giving us sound from this. But the issue that this stuff is having, at times it's not going to come up. At times if you plug our charger, no sign of charging. There's no sign of charging. There's no light. There should be a kind of light, indication light. There's no indication light. There's the indicator light. I'm looking for the indicator light. Okay, I think the indicator light should be here. Yeah, I think the indicator light should be on this panel. The indicator light should be on this panel. So let's check. Wow, something is getting hot. Wow, this chip is burning. There's a chip here which is burning. The chip here is burning. So I'll be using the microscope. This chip is burning. I think is IP. Let me use the microscope. Let me use under the microscope and let's see what's happening. So it is IP5305, IP5305. So this chip is burning, so it's not okay. But since I don't have this chip available, I'll be doing it bypassing. But I'll check if I have this chip. Exactly. I'll check if I have this chip. So let's remove this chip first. Let's try the remover. So right now, before we do the remover, you can see the data sheet of the IP5305. So I'll quickly talk about just key points about this IP5305. One of the major functions of this chip is that it is highly integrated multi-function power management SoC, that is system on a chip. The chip does the work of a charging IC, that is, it regulates and controls the charging current by IC temperature and input voltage. Another interesting function of this chip is that it's a 4-gauge algorithm acquiring battery state of charge precisely. That is, when the battery is fully charged, the chip will stop, or it will stop while giving a signal that the battery is full. That is, it will stop the current or charges going to the battery. There are some Bluetooth speaker that when you are charging it, if the battery is full, the indicator light will go off. So once the indicator light goes off, that shows the charging IC is going to regulate the current that is going from the charging port to the battery. Is going to regulate it in a way that it's not going to spoil the battery. Overcharging do spoil battery. So the charging IC is the one that will regulate and controls the charges that goes to the battery. So I think I will stop here about this IP5305. So it has so many functions. So they use the same chip for power bank and some portable chargers. So this particular IC, this IP5305, it has so many functions. You can use it for your indicator light and all. So you can go online and do research about the function of this IP5305. So it has so many functions. So I just have to pinpoint the major point I need to pinpoint that is very relevant in this video. So guys, let's go to the voice from the office. Although it might be noisy, but please guys, let's just concentrate on the information on the video. So let's go back to the voice from the office. So the chip is off. So let's try and look for the chip. So it is now. You can see the function of this the chip, which is the 5305. It functions, it controls the charging of the phone and the output. You can see this is the USB. So the USB also charge phones. So that means it does the work of synchronization between 1.0 amps to 1.2 amps. So it synchronizes. Like for example, if you want to charge your phone, you can use this USB here to charge your phone. Then this is the booster, this is the boost coil. This is the boost coil. So now we will not be making use of this USB anymore, since it's not a power bank. We just put this one as a kind of alternative. So I'm doing this working, I'm doing a kind of bypassing. So if you are charging it, it will be charging, and there should be a kind of timing, since this chip controls if the battery is full, it's going to pause the charging current. It's going to pause the charging current. But as it is now, we will not be making use of the chip because it's not even available right now. So for me to place an order on the chip is going to take time. So what I'll be doing is I'll do a kind of bypassing. So in case if you have something like this and you don't have the available chip, what you have to do, you have to bypass it. And after the bypassing, make sure you tell the customer you should not charge the gadgets to up to 1 hour. So every 30 minutes or 25 minutes, the gadget should be unplugged after 25 minutes, since there's nothing regulating or controlling the charging anymore. So I'll be doing the work. So hello guys, you can see now, right now, I've done the bypassing diagram that I'll be using to bypass so that I'll be having I'll have 5 volts on my battery connector. Then we'll be doing a kind of indicator light also. So now this is the IP5305 IC. This leg is ground. This is the battery that is going to the battery connector. This is the connection. This is the connection to the battery connector. Then we have the VCC, which is the input of the 5 volts. Which is the input of the 5 volts. Then we all know that the coil also, these two sides, if you want to check this coil if it's working or not. If you want to check if this coil is working or not, you put your testimeter on buzzer mode, then you check the two sides of the coil, and if it beeps, it's working. So this two side is connected to this battery, to this battery side. So I just drew it for reference purpose. So because you can see this is our coil on the board. You can see on the board, this is the coil. So this is what I have here also. So this is the coil. So the boost coil is 2R2, right? So this is the two legs I told you about. These two legs and this one, they are the same thing. This one, these two, they are the same thing. So the connection on this one, it's linked. They are linked to each other. This one and this one, they are linked to each other. Do you get? Then these three legs are meant for the LED. Are meant for the LED. The LED we have LED on this. We have LED on this panel. That's the what is it called? The mode, the volume up and all that. They have this touchpad sensor. So once it does not have a kind of click. It does not click. So once you touch it, it's going to respond. So it is this flex that carries the signal from these three legs that I show you guys on this diagram here. These three legs, it carries the signal to this board here on top. So we are not using that. So this one will be irrelevant for us because since it is LED, so we don't need the LED. Our one is just to bypass so that we will have 5 volts on the battery connector, so that the MP3 player will be charging, and the charging will not be more than 20 to 25 minutes, because it is this IC that regulates any maybe it protects anything like circuits, short circuit protection. It does the work of such short circuit protection. So now, since this IC is no longer there anymore, there is nothing like protection anymore. So we just have to do it, because since we don't have the chip available, so this is the only option we can fix this gadget. So we'll be using this process. But if you have this chip available with you, just go ahead and replace this. Just go ahead and replace this IC, and that's all. So I'm good to go. So let's move forward. Now we'll need a diode. There's a diode that we'll need. So there should be a diode here. So we will look for a diode that can carry 5 volts. So we need a diode that can carry 5 volts. This is a diode. So we look for a capacity diode, like a diode that can withhold 5 volts. Now we have the cathodes and the anodes, which is the plus and minus of the diodes. Now what we'll be doing now is, since we can't send 5 volts straight to the battery, we need a kind of a diode at the middle. The reason why we need a diode is because of so that the battery will not be returning charges back. So we need a forward diode, so that will be that will be sending a kind of forward. So once it's sending that current, it has no right to come back. Are you getting me? So that is why we need a diode. So we need a diode. So the diodes, this 5 volts will be coming like this. We'll have to do a kind of jumper, a strong jumper. It will be going like this. So the 5 volts will be going like this way. Then from here to go like this, to come out from here. Then to go to the parts plus. I don't know whether you guys are understanding. To go to the part plus, right, to come to this place. So that is soft like that. So if you do this solution, if you do these workings, we'll be having 5 volts on our battery connector. Do you get? We'll be having 5 volts on our battery connector. Now, since there is no this chip there, so how do we know that when we plug our charger, the thing will be indicating? So there's nothing like indication. So we have to create a kind of indicator light ourselves. So now I will draw a kind of indicator light here. So this is our indicator bulb, and we need a resistance. So the resistance that will be here will be R105 resistor or 102 resistor. Do you understand? So is either I use 105 or I use 102 resistor. Do you guys get? So what I'll be doing now is this 5 volts will be going to this 5 volts. Look at it. This 5 volts will go to one side of the resistance. Then on the other side, it will go to the positive side of the LED. This is the positive side of the LED, and this should be minus, which will go to the ground. So this one will go to the ground, so which is G and D, which is the ground. Do you guys get now? So this is the what is it called, the plan at which we'll be using to solve this problem here. So let me just go straight to the workings. So I'll not be able to do a video. So I'll not be able to do a video coverage on that. So what I'll be doing is I'm going to forward the video. So after I'm done with the working, I'll show you guys. Then I don't want the video to be lengthy, so let me go straight to the workings. So at this junction, we'll be making use of a Schottky diode with the code of SB140. So that's the value, SB140. So you have to look for a Schottky diode like this, because it can the heat that it will be generating, it will not be much like that. That is why we are using a Schottky diode with SB140 value. So you can see I've done the soldering already, so I can't leave it like this, but we are going to test. So after testing, the reason I will be testing is, diode has a forward it allows current to flow in forward direction. That's the function of a diode, one of the function of a diode. Then now the reason why I have to put that diode is for us to get 4 volts on the battery connector. So we'll be having 4 volts on the battery connector. So let's check. What do we have? So we have 4 points of 5 volts. So we are having volts, but there is no indicator light. So we'll be doing the indicator light right now. So you can see that is our on the book we have here. We have that's a SB140. That's what is there. SB140. Since we are using a Schottky diode, that's it. SB140. SB140 has, I think, 1 amp. Can carry 1 amp. So we'll be working on the indicator light right now, since we have 4 volt on the battery connector. So right now you can see on the video we have a scrap board. So we want to remove a LED diode from that one. So we'll be putting it beside the charging port. So immediately we plug our charger, we'll be having a kind of indicator light is going to indicate. You get. So on this place now we have 2 batteries. So definitely, since we have a 4.9, that's approximately 5 volts, so we can charge the 2 battery for 30 minutes. So we have to give the customer a kind of timing, so he will not be leaving the Bluetooth speaker for light for too long, since there is no IC that will be doing the regulation anymore. So let's do the remover. So like I said the LED diodes will be removing one from the scrap board, so that anytime we plug our charger, there will be a kind of indicator light that yes, our charger is being plugged. Because if there is no indicator light, how will you know that the charger is being plugged correctly, or the what is it called, the battery is charging? So we should have an indicator light. That is why we are doing what we are doing. So right now, if you've not subscribed to our channel, don't forget to subscribe. If you are a new subscriber, like I said, don't forget to hit the subscribe button. And if you've gotten 1 or 2 information from this video, don't forget to like also. And if you are a returning subscriber, don't forget to like this video. So you can see I'm done with the gummy. So you can see I'm done. So let's try and couple it.
Welcome to use Zealot products. Bluetooth mode.
You can see charging. The light has gone off. So it's on. So it's working properly. So at this junction, if you love this video, don't forget to like and don't forget to subscribe. You all know this is Tech Mobile Phone Clinic. Thank you for watching.